Next speaker is Dr Iona Alexander, and she will be talking to us about sleep and eye disease.
It's absolutely brilliant being here. You all seem really friendly, so I'm feeling less nervous than I thought I would do, and hopefully that will continue till the end. Our world is absolutely full of clocks. We get up in the morning and we schedule our day and we go to bed at night. And it's really important that our physiology corresponds to that. There's no point getting ready for bed at 10 o'clock in the morning when you're meant to be at a meeting. And so as the world is full of clocks, so is our body. Absolutely everything in our body ticks to time. So it's full of 24-hour clocks. And the clocks I'm interested in are our physiology and behaviour. Physiology is our melatonin cycle. I like it because it's called the vampire hormone. So at night it comes out, and during the day it disappears. And it supports everything we do at night, which is our sleep. So during the day we're awake, and at night we're asleep. And so every day is the same pattern. So you get a column of activity and you get a column of inactivity. But a clock isn't a clock unless it's set to local time. And so in our brains is what we call the master clock. It's rather like a conductor. It beats time to 24 hours, and all of our organs and our cells pay attention to it. So our organs and cells are like orchestral instruments, and the brain is saying we're going to beat like this, like the conductor. If you take the conductor away, I'm sure you've all heard an orchestra without a conductor. Well, our clock has to be set to local time. Local time is our environment. There's no point me as an individual having my rhythm if it isn't the same as yours. Hence we're all here during the day. And the interface between our bodies and the rising and the setting of the sun, which is our environment, is our eye. Light passes into the eye, it goes up into our brains, and our brain, the suprachiasmatic nucleus, the master clock, tells everything in our body when to tick time. So we're not only in tune with ourselves, but we're in tune with each other. As I said, I'm interested in sleep. And the reason I'm interested in sleep is that sleep allows our bodies to heal. It helps all the chemicals we've used during the day balance out. After sleep, we're better after learning. It helps our learning. It consolidates what we've been doing. It makes new connections. And if you don't sleep, if you're anything like me, if I have a bad night, I am insufferable. I'm really grumpy, I'm moody, I'm more anxious, and a lot of the chemicals that look after our sleep also look after our mood. You're going to be more tired. You might have quite a lot of health problems. If you're not sleeping at the right time, it could be because your brain doesn't know when it's daylight and when it's night time. But it might also be because you're not doing anything during the day. We live quite sedentary lives if you work in an office, which I'm inclined to do. If you're an athlete and you're out running all day, you're going to be more tired than I might be. And so as scientists, we have to be really careful and say, is sleep a problem because it's a problem or because our biology is out of place? And here's a really ghastly graph that I cannot bear, but it's the only one we've got, and it's really, really important. What it shows is a line that says S, and that's our propensity to sleep. During the day, we build up sleep pressure to the point at which we're so exhausted, by the time it comes to night time, we fall asleep. That is because our circadian system, our biological clock, is saying, stay awake. You might want to have an afternoon nap, but our biology is having none of it. Now, we do have afternoon naps, but hopefully you get the point. And so we have to be careful that when we say someone's got a sleep problem, that we know whether it's behavioural or biological. But going back to the eye, I told you that the eye is really important, and the aspect of the eye that is important isn't our visual system. We've got rods and cones that help us see each other, but there's another element of our eye which has got photosensitive retinal ganglion cells. Now, the wonderful thing about science is everything is utterly unpronounceable. So we call it the non-visual system. So we have our visual system and our non-visual system. Our visual system is interested in a vast array of light, of wavelengths, but our non-visual system is really only interested in short wavelength light. which is blue, the colour of the sky. So this short wavelength light goes into our eye. That tells us the environmental time. Our brain then tells the rest of our body to stay awake or to go asleep. So it tells us what time it is. So you're awake during the day, you're asleep at night, and your physiology supports this. So your vampire hormone, as you're going to sleep, is rising, telling your body to do all the sleep stuff. It peaks at about 4 o'clock in the morning, and then it dissipates when the sun comes out. So if you get rid of the eye, you're still going to have a behaviour that's got a daytime and a nighttime, but it won't occur at day and night, and we call that free running. And what it looks like is instead of getting up at 7 o'clock every morning, you'll actually gently drift, and you'll get up later and later and later till eventually your day is night. That's what your physiology would do. So if you don't have an eye, that's what would happen. But actually not having an eye isn't what it's all about, because if you're photosensitive, you're not going to see the sunlight at the right time. Or if you don't have access to light, if you're in hospital, the lights are often on all the time. Or if you descend into a cave, which is what this chap did. So this is just a graph to show you more gobbledygook, but what the whole point is that you can see that instead of a column of regular activity, it's drifting. So this person's getting up later and later every day. They have a fully functional eye, but they are actually in a cave. The other thing is you might have eye disease. So eye disease might have an impact on how much light is going into your brain. So we ask questions in our laboratory about what actually is blind. What is it if you don't have an eye? And what if you do have an eye? Can you still have a rhythm that is going to be rising and setting with the sun, where you'll be active during the day and inactive at night? And this individual, there's a few individuals who are blind, so they have no light perception at all. But if you actually measure their activity, they'll be awake during the day and they'll be asleep at night, but their physiology will also be doing what it's meant to be doing. So their vampire hormone comes out, it peaks at about 4 o'clock in the morning and disappears. And this is because although they haven't got their visual system, they have got their non-visual system. And this is crucial because in the old days, eyes used to be removed. And they're not so much now, because if you take an eye out, you could well be in trouble with your non-visual system. And that's what happens in anophthalmia. So this is a condition where you're born without eyes, or you can have your eyes removed for various reasons, which may be eye disease, which is more rare now, or due to trauma. And as you'll remember, if you remove the eye, you don't have the light input into your clock anymore in your brain, and so you'll be free running. And generally we would think that this would look really, really pretty. But actually it looks an absolute mess, because you don't, in real life, unless you're in a cave, but in real life you don't actually get up later and later each day, because usually your friends or your family or your school or your work schedule get really fed up with you. And so what will happen is you'll whiz along how you would, you get up later and later, then all of a sudden someone will want you to go to Manchester by train. So the day before you're naturally getting up at midday, then all of a sudden you have to get up at 7 o'clock in the morning, catch a train, and then it all carries on again. So you're working against your clock. If you're working against your clock, you're getting up when really your body's saying you want to go to sleep, you might well start to feel a bit unwell. And we find that if people are doing this, their anxiety and depression scores are quite high. So their mood's not brilliant, and they're not feeling so well either. But as I said, it's not just about what your activity's doing. We need to measure physiology as well, because there's individuals who it will depend what they're doing as to when they'll get up. So if someone is at home alone, they may well just do what they want to do, which is not have a sleep period per se, but nap and doze and nap and doze. But if their husband is at home, they're more likely to stay in bed during the night time, but they're not actually sleeping. And if in these people you measure their physiology, it's just like they're in a cave. Their melatonin hormone is coming out later and later and later. So these are people without eyes. But what about people who are blind? I mean, what is blind and how blind is blind? And I've said to you about people's behaviour, you can be active during the day and inactive at night, but your melatonin, your vampire hormone, supports all your nighttime activity. So what happens if you've got to go to work? So you've got to be active during the day. What's happening with your physiology? Well, this laboratory in Surrey, Lockley and Skene, showed that melatonin is really powerful. It's quite soporific. And this person was assessed, and they found that although they were active during the day, when their melatonin was peaking, they had a nap. So the melatonin, there's a graph up here that's got melatonin, which is circles with stars in it, that's later and later, that corresponds to the black bars, which is when they're having a nap. And so this group said, well, hang on a minute, is melatonin, this vampire hormone, important? Well, we know it's important for sleep, but what happens if you've got no light perception, or you've got light perception? Will you not have as much melatonin? And will your sleep quality be worse? Well, interestingly, the people who had light perception and the people who had no light perception had a similar perception of their sleep quality, which is a bit odd. And also their melatonin levels were the same. So although they're working against their clocks and they're struggling to do their day-to-day cycles, their melatonin is still carrying on doing what it's doing. The melatonin doesn't adjust. It doesn't go, well, I'll have a day off. It just doesn't do it. But the interesting thing they found was that if you have light perception, you're more likely to be what we call entrained. So you're more likely to get up in the morning at the same time every day and go to bed at the same time every day. But if you have no light perception, you're more likely to be free running. So you're going to be struggling to get up at the same time every day. Well, as you all know, light perception and no light perception is quite a crude cut-off. So we started to say, well, at what point is it that your vision is completely going and your non-visual system is going? So how much light perception do you have to have before your circadian system is going to be disturbed? And the health of the eye is where we turned our research. And cataract is a clouding of the lens. So you'll know that if a lens is clouded, you're not going to get so much light in the eye passing to the brain to tell your body what time of day it is. Well, this is great news because you can actually have a really simple surgery that'll take out your cataract lens and put a nice new one in. But infinite wisdom suggested that you could have two lens types. There are several, but I'm only going to talk about two. One is a clear lens. It lets all wavelength lights through. And the other is a blue filtering lens. And if you cast your mind back, I've told you that the non-visual system is interested in blue light. So what happens if you put a blue filtering lens into someone's eye? Okay, they're going to see, but are they going to have sleep problems? So it's quite difficult to measure large sample sizes with endless melatonin sampling. We'd love to do it, but people aren't always keen. And you mustn't dive in too quickly and ask too many questions. So we asked individuals what their sleep quality was like, because generally people know if they sleep well or not. We asked nearly 500 people who had a clear lens and nearly 500 who had a blue filtering lens. And what we found was that there was absolutely no difference between the two lens types. There's all sorts of reasons that could be, but what we were really pleased to show was that if you have a score preoperatively of poor sleep, it's more likely to be better after your operation. So doing cataract surgery not only improves your vision, but it also improves your sleep. What was puzzling was that this wasn't sustained after a year, and we have no idea why not. But we're quite excited about this because there's individuals with RP, retinitis pigmentosa, who might have cataracts, and generally this surgery is not carried out because people think, well, you can't see, why do you need to have your cataracts done? Well, of course you need to have your cataracts done. There's no reason not to. And now we know that maybe sleep might be improved, which would be really helpful. So what about severity of disease? Well, we have a group of people that have got glaucoma, and this is a disease of the optic nerve and interocular pressure. And what you find is that your visual fields start to deteriorate. And it's quite important because we thought, well, maybe if your visual system is deteriorating, maybe your non-visual system is too. And we took a bunch of control people and a bunch of people who've got glaucoma, and we found that, yes, they did sleep worse. This is quite important because if you rock up to a clinic with eye disease, you're probably not asked how your sleep is. And this is possibly really quite important because sleep affects so much of your daytime function. I said about severity, so the worse you sleep, the worse your disease. But we chose people that got mild, moderate and severe glaucoma and found no difference at all. But what was really strange was that there was nobody who had no light perception. So in Oxford, it would appear that everyone that came through our clinics at that time had quite good vision. So we need to go back onto this and say, well, hang on a minute, you might have good vision, but what about if you're severely visually impaired? This really might be very, very crucial. There's diabetic retinopathy, so it's a different area of the eye where the retina is threatened for all sorts of reasons. And we found in this population there was no difference between controls and people who had diabetic retinopathy in their sleep quality. So if you have glaucoma, you're more likely to have sleep problems. If you have diabetic retinopathy, you're more likely not to, perhaps. But again, we don't have people who are severely blind. And severity of diabetic retinopathy made no difference whatsoever. We have another disorder, retinitis pigmentosa, and they did sleep worse. So glaucoma and RP seem to be conditions where people sleep worse. But there was no difference with severity. But RP is quite rare, and we didn't really have very many people. So we can't, although it looks like the people who've got very severe RP should have worse sleep, there's more people who have severe RP than don't. So it might not be true. That's my caveat. Age-related macular degeneration, no difference at all. And severity made no difference either. So we're seeing that although the eye is very important, different eye disorders and different eye diseases have a differential impact on whether we sleep well or not. So cataract surgery leads to improved sleep. Glaucoma and RP are associated with worse sleep. Diabetes and AMD makes no difference. However, you could argue that not many people in our population were blind, which is quite exciting in a way, because if you have got this disease and you turn up in clinic and you might have sleep problems, well, if you've got severe visual impairment, you really should be asking these questions, and we need to do more work on it. But it's not always disease specific. If you have eye disease and poor sleep, maybe you just need to be treated. So we're now looking at the whole cohort of all of our eye diseases and taking people who have poor sleep, and we're going to be asking whether giving people melatonin, our vampire hormone, will help set their clocks or help them with their sleep. Anyway, I'm sure you're all far more interested in aniridia. Actually, we haven't got the faintest idea. There's a couple of studies which I'll tell you about. We don't really know about the eye and sleep for this condition, and there's obviously photosensitivity that's involved in it as well, so we have to consider that too. But what's quite interesting is PAX6 is involved in pineal development, and individuals who have this are more likely to have lower melatonin. If melatonin triggers everything that you're doing at night, then how's your body coping with this? So Hanish et al. Have done some quite good work on this, and they have shown that the pineal is smaller in individuals with the PAX6 gene mutation. And it's small numbers, 17 control participants, but this is probably okay. They also found that the melatonin levels were lower in the morning than the control ones. Now remember, melatonin is dissipating in the morning. It's peaking halfway through the night, but irrespective of that, there's lower melatonin. Well, it might be driving the sleep problems, because parents of children with PAX6 report worse sleep. But it's a bit complicated, because in this crowded table, the age group is 10 to 19 years. Your sleep duration changes over your lifetime, and it's at your longest when you're a teenager. There's nothing you can do about it. It's at your longest when you're younger, but your latest when you're a teenager. And there's nothing you can do about it. So you're going to naturally be going to bed much later, and a 10-year-old is very different to a 19-year-old. But I found it curious, because if you look at the weekday times of how long these individuals slept for, it's actually quite short. It's about 8 hours. But the sleep duration was not different between the controls and the individuals with PAC6. It was how long it took to go to sleep. And I think that's interesting, because if it takes you longer to go to sleep, is it that you're having trouble going to sleep, which is a sleep condition problem, or is it that your melatonin is still hanging about? It's not saying it's night time. So are you naturally a very late person? So this shows that the individuals who were trying to go to sleep struggled if they had the PAC6 mutation than compared to the healthy controls. So it was two studies that are telling you that it might be interesting, and it's done in children and we don't know about adults. I work with 1 million people. I do very little in comparison to what everyone does, and these are all the people. So I really work with Susie Downs, who's the clinician in the eye hospital. Russell Foster's the head of the Circadian Neuroscience Institute, which is where I work, and then all these people helped collect the data, and we all supported each other in doing our work. And that's it. Thank you very much.
Okay, any questions? Diana?
Nice easy ones, please. Yeah.
Sorry, I have problems with sleeping. A few years ago I lost my sight in my right eye and it's totally black. Would that affect it?
Well, your non-visual system isn't working. No, your visual system isn't working in that eye, but we don't know about the non-visual. And there's suggestions that the non-visual is a little bit more robust than the visual. But if your other eye is okay, it should be compensating for it. I say should. Well, this is the other thing. So glaucoma, we think people sleep worse, but it is possible. It's a very wishy-washy answer, isn't it? There's all sorts of things you could do. So if you're having regular access to daylight in the mornings, and if you're active during the day, and if your nighttime sleep quality is such that you're struggling the next day, it's possible that it could be down to eye issues. The other thing is that sometimes we think we aren't sleeping well, like all night we might be up, but the next day we discover after our 17th cup of coffee that we're actually quite functionable. That's not okay. If you need to really get going in the morning, it's not quite right either. So.
What else?
Spoke about a reduced pineal gland in some people. My daughter actually has no pineal gland at all, so I don't know how that impacts on what you were talking about. It's slightly different from what you were saying.
It is, isn't it? I haven't got the faintest idea. It's going to be the universal answer to all your questions. But we do know that melatonin is really important. So the rising of melatonin, it sort of sets everything that we do for us at our night time. So if you have no melatonin, what is the impact? Well, I'm not sure. And if it's from birth, well, this is the thing, isn't it? But if it's from birth, you may have learnt strategies to deal with it. But we just need to know, because it's so important. Sleep's just very, very important.
It took us until she was 4 to get a diagnosis and do night sleep, and now she sleeps well, but with melatonin.
Yeah.
But without it, she usually say.
So sample size of 1, it sounds like it's really important.
Well, I struggle to get to sleep at night a lot. Sometimes I can't get to sleep until midnight. And you see, at my grandparents I get up at 7. When it's a school day I have to get up at 6:30. And when in the weekends, I usually, that's the only time I get a lie-in, and I don't know how to cope with it because I'm very grumpy at school.
Oh, I can relate to that. You're not alone. You're absolutely not alone. There's a lot of research to suggest that school starts far too early. And so part of our group was trying to get UK schools to start a little bit later, which went down like a ton of bricks. And what they've found is that lots and lots of children are having to get up too early, and then they're sleeping in during the weekend. But if you have a confounding issue of eye disease, it's quite possible that you're being amazing by going to school and staying at school and then at the week sleeping it. You just have to deal with it, and that's not okay at the moment. So we're trying to understand a lot more about it, and that's why it's so important. But you're not alone. That's no help whatsoever, is it?
I have a couple of questions about the operation of melatonin and how it kind of governs the sleep-wake cycle.
Oh dear.
Just because I haven't seen it anywhere else, and you may know. So if you did have a pineal gland that sort of wasn't working very well, does that affect in the morning if you got exposure to light? Is it kind of cleaning out the melatonin from the system, or is something else doing that?
Well, if you haven't got a pineal that's functioning, you're probably not producing the melatonin. Well, melatonin is produced in other places, but it is considered to be quite important.
Yeah.
So,
well, if you were supplementing.
So if you're supplementing with melatonin, they're done on slow release or fast release, so your body breaks it down. So I think the whole point of taking it is that it either sets your internal clock, so instead of the light coming in and telling your master clock what time it is, the melatonin will be doing it. It has been shown to do that. It has to be appropriately timed.
Right.
And it seems from our sample size of 1 in the corner that if you do supplement with melatonin, that it will help. Have I answered your question at all?
Yeah, sure. One other question similar, which is, do you know, because I've seen conflicting things, is if you are supplementing or if it's naturally produced melatonin, is the dosage or concentration particularly significant, or is it just kind of having it or not having it at some threshold level?
No idea is the short answer, and the long answer is timing is really where I'm a bit more clued up in, because as I said, melatonin comes out at night. Now we all know when the sun goes down, but if you're what I called free running, you're not necessarily going to be operating on a day-night cycle with the environment. You'll be on a day-night cycle of your own internal rhythm. So at some point at 10 o'clock in the morning, you're ready to go to sleep. So the important thing with the timing is to make sure that you're doing it at bedtime, and your internal bedtime, not when everyone wants you to go to bed. And that can take a while to come around. There is evidence to suggest you can just bang it in at any time, but it is awkward. But I think really the timing of melatonin is considered to be very important, because it's appropriately timed means that you get a better result. But people do it where they just put it in half an hour before you're meant to go to bed. As for the concentration, I've seen conflicting reports on it, and I haven't worked on it yet.
So if you think you have sleep problems and you want to maybe try melatonin supplement, how would you go about it? Because it's not licensed in the UK, is it?
That's not licensed, which is why we're doing a trial to try and get it clear that it really does help. So I can't really tell you how to get it, because that would be naughty. Be really naughty.
So I've had a personal experience. So I know that I've got a smaller than average pineal gland through doing research in America. I'm totally blind, no light perception at all. And I've got glaucoma, so all those things. I went to a neurologist, I went to my GP several times, finally got a neurologist appointment and was prescribed Circadin, which is a slow release melatonin, and it did work a little bit, but not as much as the actual normal melatonin. And so now I have antidepressants that I use for sleep instead of melatonin.
And do they work?
Yeah, I find they
Great.
do work. Yeah.
I'm all for it. If it works, that's fantastic. We've got a lot of research that we really, really need to do. A lot of the sleep work is based on insomnia or pre-existing sleep disorders. On all of our work, if you have a pre-existing sleep disorder, you're not allowed to participate in our studies. We're specifically interested in eye disease. As a result, we do tend to take out, sometimes sleep apnea might be linked to the development of diabetic retinopathy due to raised BMI and all body mass index and all sorts of things. But we really haven't made these links of how to help people who have got sleep problems, and we're really hoping to do that with our next big study, which should be starting soon. And hopefully it will mean that when you go to your eye consultant, you will be asked about your sleep and treated accordingly. But at the moment, as you know, it's not the case.
Where else in the body is melatonin made?
The retina.
I was just thinking about with Aniridia and the retina's not always developed, is that also going to play a part in it as well?
The theory would be more than likely.
Yeah, that's really interesting. I have had sleep charts if you're interested.
Yeah, maybe. Yes, I've got a son that doesn't sleep a lot. In fact, we used to go to bed about 10:30 and he'd still be up 1:30 in the morning. He never had a screen in his room, though, I have to say. Anyone else?
At the back there.
There's one behind you.
One more question.
Okay. What I'm thinking is that I suspect my body clock creeps a bit, probably back an hour a week, I would say. And as you've sort of said, melatonin's not licensed here. Any other ways of sort of regulating it? I mean, an example I have is I tend to find doing longer days can actually work for me. Like when I've done over to the US, going over is a lot easier. I just drop into their time zone. Coming back, I can't do it. So, like say, if I have got to getting up late and then I've got to get up early for a meeting, I do a couple of long days. Like, sort of going, that's one way I've done it. I just wondered if you...
I think that's brilliant. That's why it's so important that everyone is talking, because we're stuck in our laboratories with our microscopes and it's not really real life, is it? I've talked about light, and they call them Zeitgebers, good old science, and it means that it's the main thing that sets your clock. There's also non-photic Zeitgebers, so non-light stuff, and that's things like regular meal times, regular activity, just keeping everything absolutely regular. So you get up at the same time, you go to bed at the same time, whether you want to or not. You eat your meals regularly, and it's meant to help. It does help, but it doesn't make it completely better, and it probably completely depends on who you are.
We need to move on, right? Thank you very much. That's excellent.